Sample problem 8.05. A food shipper pushes a wood crate of cabbage heads, a total mass m equal to 14 kg, across a concrete floor with a constant horizontal force F vector of magnitude 40 Newton. In a straight line displacement of magnitude d equal to 0.5 meter, the speed of the crate decreases from v0 equal to 0.6 meter per second to v equal to 0.2 meter per second. First question, how much work is done by the force F vector and on what system does it do the work? So in this question, we are going to find what is the work done on this wood crate by the applied horizontal force of magnitude 40 Newton. And here, this wood crate full of cabbage, the total mass is mentioned here as a 14 kilogram. And also they mentioned we applied a 40 Newton of horizontal force. That means we applied the force in this direction. So the magnitude of this force we applied here is 40 Newton. And also because of this 40 Newton applied force, this wood crate will have the displacement, straight line displacement. By that it will have the displacement value d, which is equal to 0.5 meters. That means the value of the d here is 0.5 meter. So the force is in this direction, by that the displacement also in the same direction. So that means here we have to consider the angle theta equal to 0. Why? Because the applied force as well as the displacement will take place in the same direction. And also the clear information they mentioned, the surface is the concrete surface. That's the reason its speed, after we applied 40 Newton of force, its speed decreases from 0.6 meter per second. That means the initial speed after we applied 40 Newton, the initial speed they mentioned here is 0.6 meter per second. And it has the final speed because of the friction. So the final speed they mentioned here as 0.2 meter per second. So now we have to find what is the work done on this wood crate by the applied force F vector. So here we have to consider the formula work done, which is equal to Fd cosine theta. So the applied force as well as the displacement will be in the same direction. So I told you already the theta here is 0. So cosine of 0, which is equal to 1. So now I'm going to substitute the value here. The applied force, the horizontal force magnitude is 40 Newton multiplied by the displacement is 0.5. And also the most important thing, the angle here is 0. So cosine of 0, which is equal to 1. So 40 multiplied by 0.5, we got the value of 20 joules. And here we have one more question on the same. So we have to give the answer on what system does it do the work. So here we have to see the speed. The speed get reduced from 0.6 meter per second to 0.2 meter per second. That means it has some frictional energy. That means the frictional force will be there. So the most important thing here, because of the frictions, what happened, its speed get reduced. That means here the work is done on crate floor system. That means the wood crate as well as the floor, because of the frictions, its energy get changes. Clear? So for that we have to give the answer. Therefore, the system on which the work is done is crate floor system, because both energy changes. Now we have to come for the second question. So what is given in the second question? What is the increase in the thermal energy of the crate and floor? So here for finding the increase in thermal energy, we have to use the rule work done, which is equal to the change in mechanical energy. We studied in the theory the change in mechanical energy plus the change in thermal energy. Now here we are going to find the answer for this one. So we have to rearrange this equation in terms of a change in thermal energy. By that what we will get, the change in thermal energy, which is equal to the work done minus change in mechanical energy. Clear? Now work done, we already got the answer from the first part. But what is the mechanical energy? The mechanical energy is the combination of potential energy with kinetic energy. So if we substitute this energy for the mechanical, what we will get, change in thermal energy, which is equal to work done minus of change in kinetic energy plus change in potential energy. Clear? So now we know what is change in kinetic energy. Kinetic energy final minus kinetic energy initial. Likewise here, final potential energy minus final initial potential energy. So now for this we have to substitute the value. So when you substitute the formula for this energy, the most important thing here, the wood grade system is on the horizontal floor, so there is no potential energy, so this part will be 0. So only we have work done and change in kinetic energy. So now I have to expand this formula by substituting the formula for the kinetic energy. By that, this equation becomes change in thermal energy, which is equal to work done minus kinetic energy final minus kinetic energy initial. Now I am going to substitute the formula here. So work done minus half m v final square minus half m v initial square. So v final value and v initial value, already they gave the value in the question. So the initial speed they mentioned in the question as 0.6 meter per second, and the final speed they mentioned here as 0.2 meter per second, and the value for the work done, we have to get the answer in the first part. Let's we go back to the question for the first one. So here we got the answer for the work done here is 20 joules. So I have to substitute the value of 20 in this work done. Now I'm going to substitute the value here. So for work done, we got the answer in the first part at 20 joules minus. So let's we take half multiply by mass outside. So half multiply by mass, I'm going to take it outside. So V final square minus V initial square. Now I'm going to substitute the value here. So half, and the mass of this wood crate is 14 kilogram, and V final square here is 0.2 square minus, and V initial square is 0.6 square. Clear? 0.6 square. So now after, let's we substitute, we can cancel this one. So 2, it becomes 7. So what we have here, 20 minus 7 multiplied by 0.2 square minus 0.6 square. Let's we see what is the answer. So 20 minus 7 multiplied by 0.2 square minus 0.6 square. I got the answer here as 22.24. So the thermal energy value we got as 22.24 joules. So this is the answer for the second part. That's it. Thank you.